Hello, my name is Roxy. I have a question. What do you think all of these jobs have in common? First of all, an animation movie designer, like the one who created Penguins of Madagascar, and a robotics engineer and a bicycle engineer. It's math! You don't believe me? Well, let me take you on a ride to see if I can convince you. Let's start with animation movie designer. Anybody recognizes this guy? Who is he? That's right, that's Woody from Toy Story. Let's ask Woody to say, walk across the stage from left to right, just like that. Believe it or not, you just saw a ton of math. Where is it? To understand this, it's important to understand that artists and designers think in terms of shapes and images, but computers think in terms of numbers and equations. So to bring those two worlds together, we use a mathematical concept called coordinate geometry. So that is, we lay down a coordinate system with x describing how far something is to the right, and y describing how high something is. And in the little sliding animation, the motion animation designers call translation, the x coordinate started with a value of 1 and ended with a value of about 5. So if we want to write that in math, we know that the x in the end is bigger by 4 than the x at the start. So in other words, the maths of sliding is addition. How about scaling? That is making something smaller or bigger. Any guesses what the maths of scaling might be? Multiplication, exactly. If you want to make something twice as big, you need to multiply the x and the y coordinates both by 2. So, if you trust me on the animation movie designer, let's see how robotics engineers use maths. Robots are being used all over the world to make our lives easier, or to play football. But the maths behind it is often overlooked. So for instance, consider these football-playing robots. Their task is obviously to score a goal. And in order to do so, the robot needs to know where the goal, the other players, and itself are at any point in time during the game. How does the robot do that? The solution is that the robot navigates along a coordinate system similar to the one we saw in the example of Woody. And with the right strategy in mind, it scores a goal. And did you know that you also need a ton of math to design a bicycle? Especially one that you can fold? So for instance, when you look at this one and how it folds so neatly, bicycle designers need to find a way for all parts to be of the right size so that the tire, for instance, fits well with the frame. Well, and what do you need to calculate the size of the tire? Exactly, geometry. The tire is a circle, and geometry tells us that the circumference of a circle is 2 pi times its radius. And this is obviously just one example of how bicycle designers use maths all the time.
I told you, maths is pretty cool. It opens all sorts of doors. And now, let me introduce you to someone who's going to tell you how he uses maths in his job.
Hi, my name's Duncan and I am a bicycle designer. I was never amazing at maths at school, but I was at home fixing my bike, and that's when I realised that maths is very useful for all sorts of things. If you want to fix bikes, or design planes or rockets, you need to use maths. I've never really enjoyed fractions. I'm still not very good at them now. I have to go back and remind myself how to do it. But you know, you have to keep trying at these things, and I get better and better every time I do it. So when I was young and I was fixing my bike, my dad would always come out and help me, and he would show me some things and try me better, and we would chat about maths and how it was useful for fixing my bike and stuff like that. So I found maths quite hard, but really all you have to do is be determined, keep trying, and you don't have to be a genius to do it, you just have to keep going and you get better and better. And for me that was great because now I use it every day in my job. I use geometry for designing bikes. I use statistics for modelling some bikes, so it really is useful. All you have to do is keep trying. So I did my GCSEs in maths, and then I went on and decided to carry on doing maths for A-level, and I did further maths as well. And that meant I could go to university and study aeronautical engineering, which I really enjoyed, and maths was really useful there. And the great thing about maths is that you learn loads and loads of different skills that you can use in loads of different areas. So if I decided to go and do something else, I've got skills I could go and use in coding or designing loads of different things. So in my job I do a lot of work with lightweight materials, things like carbon fibre and titanium. So when we design a new component, we have to compare the old weight and the strength of a component to the new component to see how much better it is, how much money we saved and how much weight we've saved. So maths is amazing, it's really cool, you can do loads of awesome stuff with it. You can design bikes, you can design roller coasters, rockets, planes, cars. I really love maths.
Thanks, Duncan. And now you go and make that math word yours.